All right, so let's take a look at one of the highly missed warm-up problems that you guys had. It says Diane bought 3 pairs of jeans at Tilly's. Now remember, I always told you guys to write it. She bought 3 pairs of jeans at Tilly's. The total cost of those jeans were $36. So her ratio is 3 for 36. Which table represents the solution? Well, if I simplify this, I know 3 goes into 3 one time, and 3 goes into 36 12 times. So 1 pair of jeans equals $12. So I know that this one could be correct and this one could be correct. I can get rid of this one and this one. So now I'm down to these two. Well, to get from 1 to 12, all I do is multiply by 12. So 1 times 12 is 12. Multiply 3 times 12 and I get 36, and that's correct as well. Multiply 5 times 12, and I do indeed get 60. Multiply 7 times 12, and I get 84. So there's my answer. Now I can double check and look at this one, but if I know that 5 times 12 equals 60, I know that's not right. Okay, so looking at this one, it says the ratio of 1.5 to 5 is y to x. So that makes my y my smaller number. So here my y is my bigger number, so that can't work. Here my y is my bigger number, so that can't work. So I'm down to these two. So then I need to divide 5 divided by 1.5. And then I believe I get 3 1/3. So now I'm going to multiply times 3 1/3 until I get the correct answer. So if I multiply 3.5 times 3 1/3, do I get 7? If I multiply 9.5 times 3 1/3, do I get 13? I'm going to say no to this one. So then I look at here, 6 times 3 1/3, 7.5 times 3 1/3, and 9 times 3 1/3. All of these end up with these answers. This is another one that got you guys again because you did not swap the numbers. So it says my ratio of 3 to 2 is y to x. So here y is my bigger number. So here y is my bigger number. Here y is my smaller number. Here y is my bigger number. Here y is my smaller number. So I'm going to exit out both of those. And then I know that 3 to 2, I divide 3 divided by 2, and I get 1.5. So my magic number is times 1.5. So that means 6 times 1.5 should equal 9. 10 times 1.5 should equal 15. 14 times 1.5 should equal 21. So if I do all those calculations, 6 times 1.5, I do get 9. 10 times 1.5, I get 15. And 14 times 1.5, I get 21. So my answer is this one. Right, yet again, we see the same thing. I'm going to write my ratio off to the side. My ratio says 8 to 3.2. And then it says y to x. So my bigger number again is y. So here my bigger number is x. Here my bigger number is y. Here my bigger number is y. And here my bigger number is x. So now I've got to figure out, okay, to get from x to y, I need to multiply by something. But to find out what I multiply by, I divide. So I'm going to divide 8 divided by 3.2 to get my magic number. And my magic number is times 2.5. So that means 4.8 times 2.5 should give me 12, and it does. 9.6 times 2.5 should give me 24, and it does. 24 times 2.5 should give me 60. And it does. So my answer is this one. All right, so the next page in your notebook says proportional or not. So we're using everything we learned to define whether graphs and tables are proportional or not. So my first sentence says a proportional relationship happens when the same constant number is being multiplied. Remember that magic number I told you about? The magic number and the constant number are the same number. By the x value and the y value. So there are two main ways to determine if a graph is proportional. The graph must go through the origin. Now, if you remember all the way back to when we looked at coordinate planes, the origin was our home. So that's 0, 0 on our coordinate plane. And the x value is multiplied by the constant, or like I said, my magic number, to get the y value. So let's take a look at this. It says, look at the table below. Are the values proportional? Well, let's do our checklist. Is there a constant number being multiplied by for each value? If so, what is the constant? All right, well, I multiplied 2 times 5 to get to 10. Is 3 times 5 15? Yes. Is 4 times 5 20? Yes. And is 5 times 5 25? Yes. So I'm going to check this and I'm going to say, yes, the values are proportional. All it's asking me is my constant number being multiplied by for each value? And it is. All right, so if I take a look at this graph, and I know it's kind of hard to see, so let's go ahead and label our coordinates. So we have 3, 1. I went over 1, 2, 3, and up 1. Remember, right or left first, up or down second. Then I go over, and I see my next one is at 6, 2. I went over 6, up 2. My next one is 9, 3. And my last one is 12, 4. So if you guys want to rewrite that in your notebook so you can see it. So my x coordinate is this line right here. So my first one is 3, and my y coordinate is 1. My next one is 6, x coordinate, y coordinate 2. X coordinate 9, y coordinate 3. X coordinate 12, y coordinate 4. So how do I get from 1 to 3? Well, I multiply 1 times 3. 2 times 3, does that give me 6? Yes. 3 times 3, does that give me 9? Yes. And 4 times 3, does that give me 12? Yes. So is it being multiplied by the constant number? Yes. The other part of the checklist when doing a graph is, does the graph go through the origin? Here's my origin.